All right, hello y'all. Something happened with my first video, so I'm just gonna go through and I'm gonna kind of walk through the problems again here. I've already got all the work on the screen, so as I'm going through, you can see how we're doing. So I'm just gonna kind of explain what I had done before. So in order to get credit for the review, you guys have to work out the evens and show me all the work. So I've put the answers for the evens, but you guys have to show me the work of how you got those answers to get those extra points on the test. So the first one here, this is a parallelogram. Okay, I discussed about how parallelograms, you know they are parallelograms because all four sides, well, both pairs of opposite sides are parallel. So these ones, you see how they're slanting in the same way? That's how you know they're parallel. So that's parallelogram. So the area of a parallelogram is base times height. You find your base and your height by looking at the right angle. Okay, the 19 and the 5, that's on that right angle. So that's your base and your height. Okay, now number 3. This is a kite, but you're going to remember on the formula chart, you have to use the formula for a rhombus. Like a kite and a rhombus are like the same-ish, kind of. So it's, and I'm going to show you how the formulas look on the formula chart. So it's 1/2 times diagonal 1 times diagonal 2. So right here, this D1 is 16. That's already the whole diagonal. D2 is 9. That's, again, the whole diagonal. So the area, it's 1/2 times 16, which is D1, times 9, which is D2. And so when you multiply that, you get 72, and since there's no units, I just put U squared. All right, number 5. Okay, this is a triangle. So they say if the area of a triangle is 225, what is the height? Okay, so area is 1/2 base times height. Y'all know it as base times height divided by 2. So we've got to go here, and I plugged in, I'll just kind of walk back a little bit here. I plugged in the 225 for the area and then 30 for the base, and we don't know the height, so I left it as h. So to get rid of this 1/2, you have to multiply by 2 on both sides. Okay, because remember the 1/2 is that dividing by 2. So to get rid of dividing by 2, you multiply by 2. So the 1/2 and the 2, those cancel each other. And so 225 times 2 is 450, and that's equal to the 30 times h. And so now, to get rid of that 30, you've got to divide because originally you were multiplying. And so when you do that, you get that the height is 15. Okay, now number 7. I'm going to zoom in so we can see it a little bit better here. Okay, they say km is 30, so from k to m, that's 30. The whole thing is 30. So remember, it's being bisected, so this top half is 15, the bottom half is 15. They told us that KL is 39, and we had to figure out this part of the diagonal right there. So you're going to use Pythagorean Theorem because we have a right triangle there because all these angles in the middle are 90. And so you got 39 squared because that's across from your right angle. So c squared is equal to a squared plus b squared. So 39 squared is equal to 15 squared plus b squared. All right, and then you would subtract 15 squared here. So when you do 39 squared minus 15 squared, you get 1,296, and that's still b squared. You can't forget that you have to still do the square root. So the square root of b squared is just b, and the square root of 1296 is 36. So this 36 is half of the diagonal right here. Okay, so from here up to here, that's 36. So the bottom half is also 36. So now to find the area of the rhombus, we have to do diagonal 1 times diagonal 2. Diagonal 1, that's km, it's that 15 and that 15, the 30, which they originally told us. Then the diagonal 2 is the other one. We found that this half is 36, The other half is also 36. So 2 36s, that gives you 72. And again, we have 1/2 times diagonal 1 times diagonal 2. So 1/2 times 30 times 72. And you get 1080. Okay, and then there's your answer for number 8. So you gotta show me that work. Okay, number 9. Find the area of the shaded area here. So find the shaded area. So that's this big rectangle without this trapezoid in the middle. So you have to find the area of the rectangle and take out the area of the trapezoid. So area of a rectangle, base times height. Your base is 10, your height is 8. So 10 times 8, 80 centimeters squared. Area of the trapezoid. This is how it looks on your formula chart. 1/2 times B1 plus B2 times H. So 1/2. Now B1 and B2, guys, those are the flat sides running parallel to each other. Your bases are parallel. So 5 and 7. So 1/2 times 7 plus 5. Okay, and then your height goes between the two bases. It's 6. So 1/2 times 7 plus 5 times 6. And you get 36. And so now to find the shaded part, it's the big rectangle, take away the trapezoid. So 80 minus 36, which is 44. All right. Next thing here. Got to find the area of the composite figure below. So this is a semicircle and a triangle. So you got to find the area of the semicircle first. So it's pi r squared divided by 2. So we've got to find r. This 18 is all the way across. So that's your diameter. So to find the radius, you got to do 18 divided by 2, which is 9. So that's the radius. And so then you just plug it in. And when you get that, again, keep it to the hundredths place for this part. We only round at the very, very end. So you should get 127.23. Okay, do it in your calculator, check it out. All right, now we got to find the area of the triangle. 1/2 base times height. So 1/2, and then again, your base and your height are at right angles to each other. So 18 and 26. So multiply that, and you get 234. And then since we want the whole figure, you have to add them together. So you got to add the semicircle and the triangle together. And when you do that, you get 361.23. And so we round this now to the tenths place. That 3 doesn't do anything to the 2, so it's 361.2. Okay, next thing. Okay, composite area here. You will see a picture like this on your test, so I suggest that you work it out the way that I do. This is a rectangle and a triangle. This is not the only way you can split it up, but the rectangle and the triangle part make it a little bit easier. So first, the rectangle. We can see it's 16 by 7. So the area of the rectangle, a sub r, base times height, 16 times 7, 112. Now we got to find this triangle. The only problem is they don't give us actual direct measurements for the triangle, so we have to get them from what we already know in the picture. The entire height of the triangle, or the figure, from top to bottom is 13. Okay, this rectangle part, from here down to the bottom, that's 7. So basically you do 13 minus 7, so this top part sticking up is 6. And then we do the same concept here with the width, the base of our triangle. So the entire figure from end to end is 16. Right here, this is only to 8 centimeters, so from 0 to 8 centimeters. Okay, well, how do you go from 8 to get up to 16? That has to be 8 as well, because 16 minus 8 is 8. So the height of our triangle is 6, the base of it is 8, and so then we plug it into our formula. 1/2 base times height, so 1/2 times 8 times 6 is 24. And then now to find the total area, all you do is take the rectangle and the triangle, and then you add them, and so you get 136. Okay, next one. Okay, we got the area of a regular polygon, and we need to find the apothem. So you're trying to find that right there. So you write down the formula. area is equal to 1/2 times the apothem times the perimeter. So I plug in 77.26 is equal to 1/2 times A times 32. And so now I got to get rid of this 1/2. To get rid of the 1/2, I multiplied by 2. So the 1/2 and the 2 cancel out. So if I multiply by 2 on the right, I got to multiply by 2 on the left. So I multiply 2 times 77.26, and I get 154.52, which leaves me with A times 32. And I got to get rid of that 32, so I have to divide by 32 on both sides. And so I get that the apothem is 4.8. Now, let's talk about this 32 for a second. Okay, where did I get that 32? Okay, it stands for the perimeter. And remember, to find the perimeter, you've got to take the side length 4 and you multiply it by how many sides you have. So if you count, you got 1, so 1, 2, 3, 4, 5, 6, 7, 8. So you got 8 sides. So 4 times 8, 32. So that's where that 32 came from. Okay, 17. Now this one is asking you to just work straight forward. We got to find the area. So first thing you got to do is calculate the perimeter. Each side is 12, and if you count them, there are 8 sides. So 12 times 8, 96. This 14.5, that's your apothem. So then we just plug in 1/2 times the apothem times the perimeter. 1/2 times 14.5 times 96 will give you 696. And again, it's units squared. Okay, now number 19. It says, if the area of a square is increased to 4 times the original area, then the side length of the square had increased by blank times the original area, or times the original length, I'm sorry. So they tell us how the area has changed, and then they want us to say how the length has changed. So remember, when you go from the side to the area, things get squared. Okay, so if you're going this way, the scale factor gets squared. But if you're going the other way, well, you have to do the opposite of squaring, which is a square root. Okay, now it says to 4 times the original. So your original is going to be your base case of 1, and your new one is 4 times that amount. So 4 times 1, that's 4. And so that's the ratio of the areas. So then to find the ratio of the sides, we have to take the square root. So you take the square root of the top, you take the square root of the bottom. So square root of 1 is 1, the square root of 4 is 2. So again, look, 1 is your original, 2 is your new one. So how many times the original length? 2 times. Because how do you go from 1 to 2? You multiply by 2. Okay, last one. The perimeter of 2 squares are in a ratio of 2 to 3. So here we go, 2 to 3. That's our perimeter one. What is the ratio between the areas? Again, your perimeter is going to be like your standard. Your area is going to change by the square of this ratio. Okay, so the square of it. So from 2, you got 2 squared, right? So that's 4. And then 3, if you square it, you get 9. So the ratio of the areas would be 4 to 9. Okay, guys, so that's it. So make sure that you've gone through and done all the work, gone back and listened to what I've said. You know, sometimes watching a problem over a couple of times will help you to understand what you need to do. If you're still not sure what you need to do, well then go on ahead, look at YouTube. You know, search changes in dimension. Search area of trapezoids, area of shaded figures. All these things you can look up. So there's no excuse why we should not have good test grades, guys. This is a very easy test. So I'm confident we can do well as long as you do the review. Remember, you guys are responsible for the evens, work, and all. So I'll see you guys in class, and make sure you complete the review. Bye.